afternoon. So today's video is actually 10-4, but we left off on kind of a cliffhanger last time, wherein in 10-3, we were in the middle of this item, okay? We were in the middle of this item, so let's go ahead and finish this out. When last we left off, we figured that RT was half of the chord, because the chord got chopped in half by our radius. We also discovered the measurement of PT, that tiny little piece between the center and the chord. We used the Pythagorean theorem, and I showed you the power of having the triple memorized so that I wouldn't have to go through all of that theorem. And so we're going to finish off by figuring out what TQ is. Now, what kind of line is PQ? You have three choices: radius, diameter, or chord. P to Q, radius. It goes from center to somewhere on the circle. It is a radius. All right, all of the radii in this circle measures 13. I know that tiny little piece measures 5. So how much does this piece measure?
5.
I know the entire thing is 13. I know this little section is 5. 8. The piece that I know. 13 minus the piece that I know gives me the missing piece. In this case, 13 minus 5, which you said was 8. How do I get PT again? Pythagorean theorem. Oh, yeah. Hi, guys. Back with me, please. Thank you very much. All right. I feel comfortable that you could do 6, 7, and 8. Okay, so I'm going to skip those and go all the way down to number 10. All right, let's read out what number 10 says. In circle Q, line segment CD is congruent to? Yes.
And is equal to x plus 5, and EQ equals 3x minus 6. What is x?
What's the value of x? Okay, so I have that this segment here, which is a chord, is congruent to this segment here, which is a chord, and I know that they're congruent to each other. Here, focus here. Okay. So I know they're congruent to each other, which means they're equal distances from the center. This little piece here is equal to this little piece here. I know the measurements of each of these pieces. GQ, which is right here at x plus 5, is equal to this piece here, QE, at 3x minus 6. And that is the equation I can write. Now I get to solve for x. What do? Subtract what?
5.
Sure, I could subtract 5, or I could add 6, or I could subtract x, or I could subtract 3x. I've got like a lot of options. So you just pick the one that you like the best. I like subtracting the x because when I do that, it keeps this one positive, and I don't have to deal with a negative x anywhere. Okay, so that's what I'm going to choose. Y'all are welcome to make whichever choice you like. That's the one I'm going to go with. Now I'm going to get rid of that 6 because I need to get x by itself, so I want to get rid of all the stuff around it. So adding 6 to both sides. And now I need to get rid of, I want the x by itself. So I want to get rid of that 2. So I'm going to divide both sides by 2, and it's 11 over 2.
You don't have to write in decimal.
You don't have to write it in decimal. I am perfectly okay with this being in a fraction. Easy enough? All right. Okay, when you're ready, let's switch out our notes to 10-4. Yay, we finished 10-3. That was the exciting conclusion. Dun, dun, dun. is March the 1st. This is my 7th period class. An inscribed angle. What did that word inscribed mean?
Drawn inside?
Drawn inside. Beautiful. So go ahead and underline inscribed and then write for yourself drawn inside. So these are angles drawn inside of circles. Now, the question that might be rolling around in your head, rolling because it's a circle, get it?
Oh my God.
That was such a lame joke, right?
Yeah.
Is that we've already got an angle that's drawn inside of a circle. And that's our central angle. But that goes... But a central angle goes from center of circle outwards. Inscribed angles go from somewhere on the circle through the circle. Okay? So this is an inscribed angle because the vertex is on the circle and the sides of the angle are chords that cut through the circle. This angle creates some sort of arc. I don't know if it's a major arc or a minor arc. It just depends on how big the angle is. But I do know the name of this kind of angle. This kind of angle is called the arc. This kind of arc is called the intercepted arc. So this one right here, intercepted arc. Different than the arc created by the central angle, which is just an arc. Okay? This one's the intercepted arc. It's created by an inscribed angle. We've got two theorems. First theorem says, if an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. So the measure of the angle is 1/2 the measure of the arc. I didn't put names for angle and arc because it could change. Okay? But this leads to another fact. That is, the measure of the arc is twice the measure of the angle. So it depends which formula I use. Depends on which bit of information I've been given. If I've been given the measure of the arc, just divide it by 2 and you have the measure of the angle. But if you've been given the measure of the angle, multiply it by 2. They'll give you the measure of the arc. Okay? Let's use both of these formulas back to back, and we're going to go down to the examples and look at example number 1 and 2, or 2 and 3. Your choice.
2 and 3.
2 and 3? All right. Let's look at 2 and 3. All right. In number 2, what information have you been given? The measure of the angle or the measure of the arc?
The arc.
The measure of the arc, which means I want to use the measure of the angle equals 2 times the measure of the arc. I'm going to throw in names now so we can talk about what angle specifically. So the measure of angle N, that is the measure of this angle right in here, is N, is 2 times the measure of arc LK, the arc that angle is creating. All right? What's the measure of the arc?
62 degrees.
62 degrees. So I'm going to substitute. The measure of the... Did I put it in the right spot?
I hope you do.
Wait. Look at my formula. Did I use the right formula? Oh, I always do that. I know. I always use the wrong formula.
Sorry, guys.
Sorry. There it is.
Gosh darn it. There we go.
You guys gotta be looking, making sure I'm putting it right, because I've had too much coffee and now I'm hyper. Yeah. Sorry that I don't have white out. All right, I have the right formula now. Double check it against my theorem. Do I have the right formula this time?
Yes.
Thank God. Okay. So the measure of angle N equals 1/2 the measure of arc LK. The measure of arc LK you said was 62. And so 1/2 of 62 is, someone with a calculator do 62 divided by 2.
Listen, get a calculator.
If you've got your phone still out, you can use your calculator app instead of watching Netflix. 31.
Charles.
No.
I don't know. I grabbed an app at random.
What do we do again?
You're doing 1/2 times 62. They're telling me it's 31. Bless you.
Can I put 0.15?
You can. Did you get 31?
Oh, yeah,
Oh, sorry. Sorry.
Times 62?
Yes, sir.
Yeah, 31.
Ooh, there's the measure of the angle. I was requested to do number 3, which is asking for the measure of the arc. I've been given the measure of the angle. So I'm going to use the formula that says the measure of arc is 2 times the measure of the angle. Can you see now why I got them confused? Yeah, it's really easy to like. All right, I don't know the measure of the arc, but I know the measure of the angle. The measure of the angle is 113. So with our calculators, we're going to do 2 times 113.
$226.
226.
226.
226. Done.
That was easy.
It was.
And the way you can tell which one you're looking for is by. It has a little.
Right. The round thing on top is the arc.
If it doesn't, you're looking for.
You're looking for the angle. Does it look like that?
What do you mean, Miss? It has the round thing on top?
The round thing.
Oh, okay. I thought you meant
Round, no.
this. I was like, Miss, it's a circle. It's round all around. Okay.
You're not wrong.
Are you complaining about that? Are you serious?
All right, we're good?
Yes.
All right. Let's look at, ladies and gentlemen, let's look at the next inscribed angle theorem. It says, if 2 inscribed angles in a circle intercept the same arc or congruent arcs, then the angles are also congruent. This one is hard only because there's a lot going on in these circles, and sometimes it's hard for you to see what thing you're looking at. So let's all look very carefully at this diagram, and I'll see if I can't highlight it in a way to get it to make sense. Okay? So it says if 2 inscribed angles, so here's one inscribed angle. Okay, do you see it highlighted in pink? There's one inscribed angle. Do you see how that angle is intercepting that arc? You see it? Okay. This arc is being created by another inscribed angle. So if I look at the same endpoints, but instead of going along the line I've already highlighted, if I go along the line I haven't highlighted yet, I find this other angle. Do you see it? The pink angle and the orange angle. 2 different angles, both inscribed, but both of them are creating the same arc. When that happens, the angle measures are congruent.
So these should be congruent.
Okay, so let's look down at number 10. Okay, we're going to scoot down to number 7. Let's get down to number 7. All right, we're trying to find the measure of angle C. So I'm going to find angle C, and I'm going to highlight angle C. There's angle C. Here is the arc angle C is creating. Looking at the endpoints of that arc, I'm going to try to find another angle that is also creating that arc. So from D, I'm not going to choose the line I've already highlighted.
You got A, B, D.
Yes, sir. I'm going to choose the other lines that were not already highlighted. As he said, angle A, B, D. This tells me that angle at C is the same measure as the angle at B. This angle measure is the same as this angle measure. And that is the equation that I can write. Which now I can solve for x. I like my x's to stay positive. I always dump the negative x's. The negative ex-boyfriends, I always dump those. Sorry. I'm going to subtract 6x from both sides. I don't need to write the 1 in front of the x, so on the next line I'm not going to. I'm going to add 11 to both sides. And x equals 8. Cool?
Cool.
Yeah.
Is that the final answer?
No.
No.
Why not?
Could we do the other one?
What was I being asked for?
C.
The measure of
Angle
angle
C.
C. The measure of angle C was given to me as 7 times x minus 11. So I have to substitute. You're absolutely right. And when I substitute, I get? Use your calculator apps. 7 times 8. That minus 11.
45.
45, he says. Yes? Yes?
45.
Yep. Good. Beautiful. I'm done. Now I'm done. I must have typed something weird. When you're ready, join me on the back of the page for the last bit of this section.
Yay.
I know. Calm down, calm down. Now, when an inscribed angle is part of a triangle, okay, and one of the corners of the triangle intercepts a diameter, which ends up creating a semicircle, then the angle right here, the angle of that corner of the triangle that's cutting at the diameter, that angle is a right angle. Let's talk about why. So I got a full circle, yes? What's the degree measure of a full circle? 360. A diameter cuts a circle in half. So what would be the measure of this half circle, semicircle?
180.
Beautiful. We just learned that the measure of the angle creating an intercepted arc is half the arc, yes? What is half of 180?
90.
90. And that's why when you have a triangle or any angle and it's intercepting at this diameter, creating a semicircle, this angle's measure is 90. Okay? So now you can use that shortcut without having to think half of craziness, okay? All right. Let's practice. Let's do number 9. What kind of shape do I have inside the circle? Triangle. Good. What do I know about the angles in a triangle? They're even? They add up to? 180. Okay, that means that the measure of angle W plus the measure of angle X plus the measure of angle Y equals 180. What information do we have about the measure of angle W? It's x plus 12. What is the information we have on the measure of angle X? X. What information do we have on the measure of angle Y? Nothing, so we got to go figure it out. Look at the angle here at angle Y. There's that angle. It's inscribing what kind of arc?
90
What kind of arc?
or no?
Semicircle, minor arc, major arc?
Semicircle.
Semicircle. When that angle intercepts a semicircle, then the measure of this angle is? 90. So what's the measure of angle Y?
90.
And now I have all the information I need in order to solve this problem. Okay. I'm going to add the two x's together. I'm going to subtract 90. Now I'm going to subtract 12. You could have added the 12 and the 90 first and then subtracted. You would have gotten to the same place. I'm just trying to be lazy. 78, 88. Help, calculators. Because I'm not sure if it's 78 or 88.
78.
It's 78? Okay, thank you. And then we're going to divide both sides by 2.
2 divided by 2 is
39.
36, 39?
Yeah.
Oh, I was going to say 36. Now I have a value for x, which means I can now find the value for angle W.
Excuse me.
Yes?
Can you please send Sarah Rangel to the attendance office?
Thank you.
Thank
That's
you.
51.
51.
And that's it.
And that's it.
And the for 8 is just 39.
Look, we already did number 8. What did number 8 ask for? The value of x. What was the value of x?
39.
Poof, done.
Wow.
Let's come up. Let's grab our last theorem. Our last theorem of the day says, if a quadrilateral is inscribed to a circle, then its opposite angles are supplementary. What did supplementary mean? Sarah, go. Come back.
360.
Close?
No,
180.
180.
Yeah.
Adds to 180. That means if I were to take the measure of angle L and add it to the measure of angle N, because those are opposite angles, my result should be 180. We're going to leverage that on number 6. I lost count on this. I'm sorry that your paper goes 8, 9, 10, 11, 5, 6.
It's okay.
I failed pre-K learning to count. I'm sorry. Sorry. All right. The measure of angle S. What is the measure of angle S?
2x.
2x. All right. If I'm trying to find that measure, I know that that angle is supplementary to this angle. Right? I know they're supplementary?
Mm-hmm.
Good. So that means if I add them, I should get 180. All right, let's solve that for x. I'm going to subtract 110 from both sides. Please double check me. I'm feeling nervous about that number.
70.
It is? Okay, good. And then I'm dividing by 2, and I think that's 35. Yeah, okay. Great. So now I can substitute into here. And then when I multiply back out, the measure of angle S is,
70.
and I'm done. That's it, that's all I had.
Oh, okay, that's
And then R would just be like 3x plus 7.
Thank you very much.